Welcome to our program, Astronomy for Everyone. Before we get started, I would like to mention that with this show, we are beginning our 7th year on the air of bringing you Astronomy for Everyone. We hope you've enjoyed the previous 6 years, and we look forward to the coming years as well. The topic for this month's show is asteroids. And here to tell us all about them is our guest, Robert Trombley from the Warren Astronomical Society. Robert, welcome to the program.
Thank you.
People have heard of asteroids, but beyond that, they're probably not real clear as to what they are. So can you tell our visitors what asteroids are and where are they located in our solar system?
Okay, sure. Asteroids are leftovers from the formation of the solar system. They can be anywhere from metallic to stony and everything in between. When the solar system formed and the planets formed, they formed out of what's called protoplanets, and some asteroids went down that path. And as they got larger, a process called differentiation can happen, and you can that happened on the Earth. And like we have the image here, you'll have the heavier stuff sinking to the center, and the lighter stuff floating up to the top. And if these things during the formation of the solar system plow into each other, you can have a catastrophic destruction of these, and it can throw all sorts of pieces out into the solar system. And this is where your meteorites come from. But they can be anything from metallic core pieces to pallasites, which would come from the mantle, and stony pieces, which would have come from the crust of an asteroidal body. Now, this image here, what you're seeing here, is the main asteroid belt between the orbits of Mars and Jupiter.
That would be what's shown in green?
Yes, okay. Jupiter being that blue dot in the upper left there. You'll notice how far away the asteroids are away from Jupiter, and you can't really see the orbit of Mars there, but they're really close to Mars, because Jupiter has a large gravitational field, and it had a large effect on the formation of the asteroid belt.
Sort of pushing them in towards the center? Because
no, not allowing them to get very close.
Or to drift out.
Jupiter was a big vacuum cleaner, and it cleaned stuff up. Yeah,
all right. So are they confined just to that belt between Mars and Jupiter?
Not necessarily. There's a lot of them in the inner solar system. Those are the ones you see here in red and yellow. Some of these are called potentially hazardous asteroids, and these are the ones that can come close to Earth and could possibly hit the Earth and large enough to cause damage.
What size would those particular asteroids be?
About 100 meters, I think, is the size that can do some significant damage.
Okay.
Asteroids come in all sizes. They can start off, the definition is of about 1 meter, but they can be several hundred kilometers in diameter. Vesta is several hundred kilometers in diameter. Ceres is like 500 miles in diameter. I don't know what the conversion is there, but it was once considered an asteroid. In fact, it was the first one discovered.
That was going to be my next question. How were they discovered, when, and by whom?
Well, the first one was discovered in the early 1800s by Giuseppe Piazzi. He was a monk, and he discovered Ceres. And Ceres went through a whole bunch of different changes, because after Ceres, they discovered more, and over the course of about 40 years, they had about 18 of these things between Mars and Jupiter, and they finally threw their hands up in the air and renamed them all asteroids.
And is this sort of a running tally of some of these?
This is today's tally, as of a few minutes before this program. So there's about 681,000 asteroids. And
labeled as minor planets on this
yes,
chart.
They're called minor planets. Yeah, and
okay.
so and in 1980 we only knew of 9,000 of these things. So the discovery rate of these has exploded over the last several years. Now between the late 1800s and the mid 1980s. These things were discovered using photographic plates, and that is how they were discovered. Now, this graph here is from JPL, and it shows the rate of near-Earth asteroids. These are the ones that come near the Earth. The red line at the bottom are large near-Earth asteroids. These are about 1 kilometer or greater in size, and you'll note that graph is leveled off pretty
over
much.
Time. Yeah,
we've pretty much discovered all those. There's a few remaining that we haven't discovered. Now, that blue line is all the other asteroids, and that discovery rate is just going straight up, and as we get new technology and space telescopes, I have a feeling that slope is going to be even steeper.
So yeah, there doesn't appear to be any end in sight.
Well, we've discovered, what, about 12,000 there,
Yep.
and Ed Lieu from the B612 Foundation estimates that there's probably over 1 million near-Earth asteroids.
And so these are crossing Earth's
They
orbit?
can, yeah. Near-Earth asteroids, and there's a difference between near-Earth asteroids, potentially hazardous. Potentially hazardous are near-Earth asteroids, but not all near-Earth asteroids are hazardous. So near-Earth asteroids can come within 40 lunar diameters. I'm not really frightened about those.
Okay, so that's far enough away where we really don't have to
Yeah.
concern ourselves
Exactly.
with that.
It's the ones that come inside the lunar diameter that we got to start worrying about, especially the ones that come in the geosynchronous ring.
Okay, so the Earth is hit by these objects regularly. I
Well,
don't want to sound alarmist to our viewers.
I
but
remember in the 80s hearing about a couple near misses a year, and now you can go to the Minor Planet Center site and see near misses every single day. With the discovery rate in the 80s going crazy, the near misses have increased, and after the event in 2013. There was some global initiatives put on. They in the 1970s, I think it was, the Nuclear Test Ban Treaty. They put all these infrasound sensors around that can detect nuclear blasts. Well, when an asteroid hits the Earth rings, and they can detect that.
Okay.
And U.S. spy satellites are really good at spotting asteroid re-entry paths, and there was an agreement to collate this data, and we have discovered that between like 2000 and 2010, we got hit 26 times by what could be considered city killers. Now, most of those hit over the ocean, a couple in Antarctica. Nobody's going to care about those. But when one goes over a city like Chelyabinsk,
I was going to ask you about that impact there in Russia a few years ago.
yes, this image here's the fireball that came in. This came in early in the morning, and it came absolutely out of the blue. I get asked all the time, why didn't we see this thing coming? There's 3 reasons. It was really small, about the size of a U-Haul. It was dark. It was black as coal, and it came from sunward, and we don't have anything looking in that direction. So
Well, no, we wouldn't.
we don't yet.
The,
yet.
Yeah.
Yeah, you require a space telescope to do that, and we don't have one looking.
Looking
So
in that direction.
that thing came by and left this really cool contrail. It's just roiling smoke, and all these people in the city went up to their windows to look at it, and it was amazing. And what they couldn't see was the shock wave coming towards them. And 3 minutes later, it hit, and it blew out windows all over the city. It flattened at least the roof of one building and several others, and people got sunburn, eye damage.
Well,
windows in apartment buildings got
the shock
blown out.
wave from that.
From that, it blew out glass all over the place. And you see there was 1,600 injuries. There were no deaths, thank goodness.
Mm-hmm.
But most of the injuries were from flying glass.
From people who were
From the shock wave, looking at this really cool. So what if you see something like that in the air, don't go to the window.
Oh.
So yeah, here's an unfortunate fellow who got hit by one of these things. Now, the major injuries were flying glass. It could have been a lot worse. It came in on a very shallow angle. If it was on a steep angle, or if it was made out of iron rather than stone, it could have been a lot different.
The mass would have been much greater with an iron versus a stony.
Mm-hmm.
Okay.
So Chelyabinsk was a wake-up call, and we were very lucky.
Well, again, glad that there wasn't any major damage in the city, and certainly any deaths that would have occurred from this. We're going to take a quick break in our discussion about asteroids. If you have a question, you can send us an email, and we can bring up the email that on the bottom of our screen. There we go. Oh, that's the website. Oops, sorry. You can check that too, by the way. So either way, but if you do have a question, send us an email. It will get to us. We can forward that on to the proper person here at AFE and maybe get the information on the show for you if it ties in with one of our topics. And right after Term of the Month with Stephen Whitty, we'll be back with part 2 of our discussion on asteroids.
Thanks, Don. The term of the month for June 2015 is albedo. Albedo is sort of how bright something is. It's the ratio of the reflected light divided by the light that shines on an object. This gives you a number from 0 to 1. So 0 is dark, 1 is bright. But in this talk, we're going to be talking about percent, so multiply that by 100, up to 100. The moon is not very bright. It's very bright in the sky because it's so big, but it's only 12%. It only has a 12% albedo. The Earth, by contrast, has a 30 to 35% albedo. Clouds change it, and that changes from day to day. Enceladus has the highest albedo in the whole solar system at 99%. And that is albedo, the term of the month for June 2015. Back to you, Don.
Thanks, Stephen, and welcome back to our program. The topic is asteroids. Our special guest is Robert Tremblay from the Warren Astronomical Society. In the first part of this discussion, we were talking about the Russian impact and damage that was caused to structures and injuries to people. So it brings up the question, what are we doing to protect ourselves or try to protect ourselves from these things?
Well, before you can protect yourself from them, you got to find them. So one of the things that we're doing is we've got a lot of Earth-based telescopes looking for them. But like Chelyabinsk, those things can't see things coming from the sun, so you've got to get a space telescope up there. So one of the plans currently being done by the B612 Foundation is called the Sentinel mission. This is a space telescope that is going to be, oh, here you go. It's going to be out in like a Venus orbit, and it's going to be able to take a look at the areas where we can't see these things currently.
With the technology that we have in place.
Yes, with current technology, and this is a totally privately funded venture.
Okay, non-governmental.
Yes, and the month after Chelyabinsk, some scientists, some NASA folk, and some other specialists talked for 2 days to Congress, and they talked about space threats, solar flares, space junk, which is a real big problem, and asteroids. And after 2 days of testimony, not much has happened.
Okay, thanks for coming. We'll see you later.
Exactly.
Okay.
Not
encouraging.
It's not encouraging. Well, okay. There are some other groups. The International Astronomical Union has formed a group called IWAN, which has come up with some suggestions, and there are a whole bunch of other groups, advocacy groups out there. Myself, I'm trying to do it, but I'm just trying to spread the word. But the main thing is to just get people to know what they are, that it is a threat. And don't lose sleep over it, but just be aware that they're out there.
Okay, so we're trying to look out into space to see these objects coming.
That's the first step.
Okay. The second step, folks have seen the sci-fi movies about blasting these things to smithereens. Mm-hmm. In your estimation, how realistic is that?
Well, okay. Well,
get a little opinion here. But
the problem with a lot of asteroids and comets and things that want to hit us is a lot of them are not solid bodies. A lot of them can be fluff balls. They're not very dense. So, for instance, if you take a bowling ball and you throw it into a snowbank, that snowbank's going to go whoop and just suck the bowling ball in, and the snowbank's not going to explode. No. That's pretty much the problem with an impactor. When you throw an impactor at a comet or an asteroid, and it hits it, it might not deflect it very much if it's what's called a rubble pile or not very dense. If it's dense, you'll have a better chance. But again, if it's dense and you break it into a bunch of parts, now you're going to have a bunch of parts hitting us. So just blasting it up works great in the movies, but it's really more effective to just move them out of the way. And there's a lot of different methods for doing that. And one would think just stick a rocket on it. Well, a lot of asteroids are like doing that.
Tumbling and rolling.
Tumbling,
Yeah.
so that's impractical. The Planetary Society is working on a very promising method for deflecting an asteroid called laser beams. And what you do is you take a whole bunch of satellites with high-powered lasers and solar cells. And essentially what they do is they just form a swarm and they beam down toward a single spot on the asteroid, create essentially like a rocket jet as it vaporizes. You do that long enough and it can move the asteroid out of the way. And that's not subject to, it doesn't care about the rotation because that one spot is always thrusting out.
Okay.
The other method that's pretty interesting is called a gravity tractor. You know how gravitational forces, two bodies always pull towards each other. So if you've got a really big asteroid and a tiny heavy satellite, and you can position that satellite by that asteroid and thrust ever so slightly, eventually it's going to tug that asteroid. And it only has to tug it a little bit, but you got to do it far enough in advance for it to
Get the desired effect.
Exactly. So you've got to find them. I think 10 years is about the right time. And remember Comet Ison? When
Sure.
it came by, it was discovered, and it was discovered to be coming in toward the sun. And 14 months later, it did that. If it had been discovered to be on an earthbound trajectory, we would have had 14 months to deflect it. That's not enough.
No, you mentioned 10 years and 14 months. Yeah, no.
No, that one the only choice would have been is to throw an impactor at it and hope.
And then brace for a bunch of little
But
ones.
we
rather
don't
than
even
one big
have
one.
that now. I mean, in order to deflect these things, you've got to have something ready to go now.
And we don't.
We don't have that.
Well, hopefully they'll keep working.
I'm hoping.
Yes.
I'm trying to prod people.
The last question I have. We have pieces of meteorite here on Earth. Scientists have studied these pieces. What interesting discoveries have we made from studying the materials that asteroids are made of?
Well, we've found out how old the Earth is for the first thing.
Is that right?
Yes. Using dating techniques, again, they're leftovers from the formation of the solar system. And from the beginning of the solar system, they've pretty much stayed static since then. And when they fall to Earth, we can measure them. And with weathering and stuff like that, it was really hard for us using earthbound rocks to tell how old the Earth was. But when we had meteorites and we were able to analyze them, we were able to find that. And the other interesting thing is in some of the meteorites that we've analyzed, they have found a whole bunch of organic molecules. They have found left and right-handed amino acids. They've also found glycine, the simplest of amino acids. So the stuff of life didn't need to form here. It was here to begin with.
Okay.
And throughout everything that formed the solar system, it's everywhere.
So these basic amino acids were here.
The organic molecules, they found them in comet dust from the Stardust mission, the Stardust Comet Return mission. They found them in the intergalactic clouds that star systems are forming out of. So that was very unexpected, very exciting.
Interesting that these basic compounds are really found throughout our galaxy and other galaxies, presumably.
It certainly makes one wonder how much life could be out there, doesn't it?
In the search for life in the solar system, which was one of our previous shows that we did. Any closing remarks about this topic of asteroids?
Well, I just want people to know about them. I want people to understand what they are, and I want people to write their senators and their government and tell them to please pay attention to them, do something about them.
Okay. It sounds like we don't want to have, or hopefully try and avoid the big one that took out the dinosaurs.
Well, if an asteroid takes us out, it's because we let it. We have the technology. We're developing new technology.
Okay. It's just the will.
We need the will.
the will to do it. Okay. By the way, we have a couple of minutes. The asteroid that did wipe out the dinosaurs, how big was that?
Oh,
Any
I
ideas from the-
believe, let's see, it was about 6 kilometers across.
Which is about 3.5
Ele-
miles.
Oh, no, was it? I can't remember. It was,
Yeah, kilometers, 5/8 of a mile.
yeah, it was about 6 kilometers across. But
6
so
kilometers. So that's not a huge piece. I
It
mean,
doesn't need to be huge. It's all about kinetic energy, and if it was metal, it's going to
Okay.
have a lot of energy. And they, you know, the there's been several impacts. You know the 1908 impact in Tunguska.
up in Siberia, yes.
And this asteroid day thing here that's up here. This is a global awareness campaign that is being. It's going to be every June 30th, the anniversary of the Tunguska impact. It's going to be a global. There's going to be a day of just our asteroid awareness, and they're going to be having a big to-do in London, and they're having events all over the planet. So you can go to asteroidday.org and take a look and see where there's events. I'm trying to make one here in Michigan.
Okay, and this is, again is to raise people's awareness.
Every single year,
of
and
this issue.
there have been over 100 people signed on to this thing, famous astronauts, scientists, astrophysicists, et cetera, and these people are all trying to prod world governments into doing
Knowledgeable,
something about it.
respectful
Exactly.
people that
That's
are
it.
well respected in their fields that consider this.
Yes,
to be
some of the names on the signatory list are highly recognizable.
Okay. Well, this has been an interesting discussion, Robert.
No, I love
I know
talking about
I found it to be that way. We hope you've enjoyed the conversation as well. I do want to thank our guest, Robert Tremblay from the Warren Astronomical Society, for being with us today to bring us this interesting topic. We do want to please direct you to our club website. The website's down there. Yep, there it is at the bottom of your screen. And also you can find from our website the list of all of our past Astronomy for Everyone programs, going all the way back to program number 1. Coming up next, we will close with What's Up in the Night Sky with Stephen Whitty. Thanks for watching.
What's up in the night sky for June 2015? June 21st is the summer solstice in the northern hemisphere, and of course here in Michigan. But it is the winter solstice in the southern hemisphere, and now that we're on YouTube, we are a global show here. Sunrise on the first of the month is at 6:19 a.m. and it sets at 8:41 p.m. And at the end of the month, on the 30th, sunrise is at 6 a.m. and sets at 9:13 p.m. The 21st is the longest day in Michigan, and so the sunrise is a little earlier at 6:56, just a little bit before 6. The month starts with a full moon on the 2nd. On the 9th, we have the third quarter. On the 16th, we have a new moon. You won't be able to see that much. And then on the 21st, we have the first quarter, another evening moon. Mercury is best at the end of the month. So here on the 30th of June, we're looking at 5:30 a.m. We've got a sunrise. We've got a Mercury rise at 6:07 a.m. At the beginning of the month. At the end of the month here, we have a 4:45 a.m. Mercury. rise. You really, if you're using optics of any kind, binoculars, don't use them as soon as the sun rises. You can really damage your eyes. Venus, on the first of the month here, Venus sets at 21 minutes after midnight, which is possible in Michigan because of daylight savings and being at the western edge of a time zone. Jupiter sets after midnight also, but that's not that unusual, at the beginning of the month, and a bit earlier at the end of the month, about an hour earlier, 11:41. So this is at 8 p.m. on the 1st we're showing. Mars will not be visible because there's a superior conjunction on June 14th, so that's when Mars is on the other side of the sun from the Earth, totally not visible. Saturn, here on the 1st, sets at 5:41 a.m. It's best right around midnight. Uranus and Neptune rise, so here we're looking at 4 a.m. This is a good time. It's fairly high in the sky and so on. Uranus rises at 3:41 at the beginning of the month and at 1:49 by the end of the month. And Neptune rises earlier at 2:13 a.m. at the beginning of the month to just 19 minutes after midnight by the end of the month. And that is what's up in the night sky for June 2015. Keep looking up for the best free show right above your head every single night.